Good afternoon, everyone. Thank you for joining us for our final webinar of our Summer Exchange series. Today we have Tom Giglio from HP, and he will be discussing innovative applications with HP latex. We will allow questions and answers for the end, but if you do have it while he's talking, you can just put it in the Q&A and we will get to them at the end of the presentation. Tom?
Thanks, Tara. Good afternoon, everyone. I'd like to extend my welcome on behalf of Michael Fallagrady and myself here at HP. We always love talking about applications. We feel that really our technology is suited for those applications, and always happy to share those with everybody. So anyway, so today's presentation, just a couple things about it. We're going to talk about thermoforming, but a lot of what you may hear about thermoforming really pertains to a lot of everyday graphics as well, especially for sign decoration and some other things. So not a sales pitch today. It's pretty much different knowledge. And then let's go through it. As Tara said, we'll go through the program in the content fairly quickly. And then at the end, I'd be more than happy to stick around for questions, no matter what they are. So our approach really is about our latex printers. If you don't know a lot about our latex printers, you will in the next couple of minutes. But we are on what we call our 4th generation of latex ink. Latex is 15 years old this year. We've gone through 4 iterations of latex ink, and it is the core ink for what we call our R series printers, or our rigid printers. So we can print directly on a variety of substrates like acrylic, polycarbonate, PETG, ABS, a lot of the things that are used in forming and or sign decoration. The thing that you really need to remember about latex ink, every time we come up with a new generation of latex ink, usually the temperature in which we cure the ink comes down, so that the application range expands quite a bit. When we did launch our 4th generation ink, we did have white, and white is really made a big difference for those in the sign industry, because now you've got some extra tools for creating opacity and different types of effects. Latex ink is instantly dry. Once it comes out of the printer, you can laminate it, you can form it, you can bend it. It has exceptional heat tolerance. We can probably withstand heat up to 500 or maybe even 600 degrees Fahrenheit. Usually the material is the lowest common denominator there. The ink has excellent elongation. We don't have an ink that cracks, and it remains very, very durable. As I'll go to in the next slide, you'll see the chemical composition of latex, but because we use water as our vehicle, there's no special ventilation that's needed. These are odorless inks. They don't contain any hazardous air pollutants. And, you know, for those people that are used to UV printing, or like myself, grown up in the industry with experience in UV, you don't have a lot of that baggage to drag with you. And in this process, especially for forming, that makes a big difference. The nice thing about latex operation, daily process, is that we have presets, and those presets help you determine what you're going to print. When we had to talk about forming and this elongation and stretch, we had to create print modes that far exceeded what we would do on a normal scale. So we can actually put about 390% of ink down on a sheet of material, so that it's able to withstand tolerances like you see in the picture here. These were actually a couple of our first prints that we ever formed, and they're very rigorous tests to see if the ink will form at 180 degree bends. Ratios are really important in forming, and you can see that these inks just really don't come apart, and they don't have issues. And that's all governed by our users' ability to create different presets. So if we look at the four verticals where we've really existed in forming, one obviously is outdoor signage. A lot of the top sign companies in the US use this technology to decorate signs that are always hard to decorate. So BP is usually at the top of that list. You know, there are different ways to decorate the BP, Helios, and it can be done with translucent vinyl, can be screen printed. You know, there's a few different ways to do it, but if you have digital to get through the iterations, it helps an awful lot. So outdoor signage, second surface to polycarbonate, always really a popular application. The other thing about this that I should mention is that even if you aren't going to form it, if you want to decorate something second surface and you wanted to put some type of diffuser film on it, you know, you could put a 3633M on it. You could put some of the Envision 3M products. You could put other manufacturers' products, or you can use the white ink in the printer. So there are a lot of ways to really create some unique signage that's depending on the print run. The gaming industry has really adopted latex in a major way. And the reason for that is when you walk into a casino, if it is a printed bezel around a sign, or if it is some kind of graphic around a gaming machine, usually there's a lot of special effects that go along with it. So there are multiple layers of either ink or colors or white combinations, or maybe even some other combinations of cut vinyl. The ink is really thin. The ink is 3 microns thin, so it's about 8 times thinner than a UV printer. So you can laminate, and then you don't have any silvering or any type of effects, any effects that way. Point of purchase, we have a lot of customers that create POP signs. Typically, this is going to be polystyrene. The styrene could be bent. They could be shelf wobblers, danglers, you know, different types of signage, acrylics. And this is becoming super popular because of short runs, target marketing, all the SKU choices there are now, and all the different products. So the runs aren't nearly as big, and that's good for, I think, everyone on the call. And in the aftermarket, we have a lot of substrates here. You know, for ATVs, luggage, automotive aftermarket, bug shield, side window deflectors, you know, things like that. And, you know, even taking it to, you know, recreational vehicles, showers, shower pans, sinks, bathtubs are all being formed. And the neat thing about that is we never thought that a lot of those things could be decorated before. So now you can not only decorate them digitally, but then you can form them as well. So this just gives us, you know, about 4 verticals where we see a lot of our customers using the technology. As I mentioned before, you know, a little bit of a science lesson here. So no matter what the ink people use in a digital printer, and typically you're going to have solvent ink, you're going to have UV ink, or you're going to have latex ink. Okay. In terms of latex, we use water. We use about 65% water to transport all these particles over to the media. And that media could be a decal, self-adhesive vinyl, it could be, you know, some of the plastics that I mentioned. But we evaporate the water, and then the latex particles, which are you know, resin particles, then actually cure. So they're instantly dry when they come out. Conversely, when we look at some of the competitive products, up to 80% of their vehicle. So we have water, and a lot of our competitors have other things in that 80%. But a lot of those things are combustible and flammable, and they carry a lot of warning labels. So we made a hard stand for this a long time ago to get away from that type of technology, and wasn't an easy road. But I think our customers are really happy, and as they continue to plan for future things. You know, it's super important for them to have, you know, a sustainable product. One of the byproducts you get with a water-based ink is you get increased color gamut. There's really no market better for increased color gamut than the sign industry, because for those people that have gone digital in the past, you know, years and years ago, if you're using an eco-solvent system, you always worry about how much ink can I put down and how fast can I dry it. Because if you put too much solvent ink down, you compromise the adhesive qualities of the product you usually put it on, or the, you know, the flexible fabric or whatever you're printing on. With latex ink, one of the nice things you get is you get an extended gamut, because when we have that water, we can put more pigment in the water without getting penalized for things like adhesion. So if I were a UV print ink manufacturer, I only can get so much adhesion and so much color. Sooner or later, I'm going to have to force the customer to choose. If you want more color, you're going to get less adhesion, and vice versa. And with that, you see a lot of manufacturers offering multiple ink sets. Some people have 2 ink sets, some people have 7, some people have 4. With us, you get 1 ink set. It's the same ink set you use every day. So if you want to make McDonald's red, as you can see on the slide here, you know, it's outside the gamut of some of these other competitors, but it's well within inside the latex gamut. Same thing with Coca-Cola red, same thing with, you know, 123 yellow on the Visa sign. So these are really important, not only for you to be able to match those colors, but if you ever start taking some of your analog process, your cut vinyl or your translucent vinyl, and you want to lay that down on a sign face, now you have a really nice ink set to do that with, and you have a really good chance of making a good match for that color. You know, we love doing demos for people, and whenever people come and do a demo with us, they bring in their colors of their most important customers. Could be 10, could be 20, 30 colors. And then we just like to see where are we going to match those colors. So we adjust a few knobs and handles, and then we usually end up matching probably 90 to 95% of them, you know, as good or better than a pigmented vinyl. So anyway, we're better in warmer tones, so reds, oranges, yellows. We do pretty well with those. So I don't know how well this video is going to play. So I'm a newbie to Microsoft Teams. So I'm going to play this short video. This is a PETG sample. This was something that we created in early testing. I think we might have done this 4 or 5 years ago, but I like to show this because it's a bit extreme. It shows that we printed whites and latex and colors in line, and we printed them on a piece of PETG, and then here's a Mac former, which is showing about an 11-inch draw. So I'm gonna just show this. Hopefully it's not stuttering, but you can see how this ink stretches and does not crack or craze or do any of that weird stuff. And then it survives the process. What's a bonus here is the fact that this ink actually touches the tool. So a lot of times that's a no-no when you print with digital ink, because when it touches the tool, it starts to fracture or stick. So this is a fiberglass tool with a mold release agent. And the mold release agent didn't get to the ink, and the tool wasn't too abrasive. So another sample, and I'm going to play this while I talk. This is a PETG sample. This is a test that we did when we created the maximum density of our ink, because we didn't want this black ink to be any less rich. And then we wanted to understand not only in thermoforming, but in stretching of the plastic, because some sign faces you have to pre-stretch the fabric or the substrate. So we wanted to make sure that we weren't coming apart in any of this. Now, this isn't the fastest print in the world to print when you print with that much ink, but it is one that survives, 20 or so inches of stretch. So anyway, that's kind of a nice one too. So you might be asking yourselves, okay, I get it. Okay, you have a mold, and then you take your image, and then you heat the plastic, and then you put it in a former. But how does the image line up? So we like to call that distortion printing. Okay, and the distortion printing process is carried out in one of three ways. Okay, so in this case, I'm trying to get a tiki mask to align to a tool, a mold. So I can either do it trial and error, and there are a lot of people that do trial and error. Okay, there's a lot of people that'll say, okay, look, I can get that image, and I can make it fit my mold, but it's going to take me 6 or 7 tries. And to be honest, sometimes people have the time to do it and the expense to do it, and it's kind of been normalized. Okay, so that's the first one of three. The second one is you can go invest in a system of software and cameras that will actually scan the mold and then adjust your artwork for you. Okay, now expensive, probably about 35 or 40 grand to do something like that. But if you do enough of it, and you don't have time for trial and error, and you don't want to go through that expense, then that's the system for you. That system actually is from France. It's a system called Quadraxis, and it's a company that writes the plugins for popular illustration and photo programs. And then they also integrate all the cameras as well. And then the third option is what I'm showing you here. It's a company based in Toronto, or just outside of Toronto, called Distortion Arts. And personally, I've known these people for, gosh, I don't want to date myself. It's probably going on, 15 or 20 years now. But Distortion Arts is really a service bureau. So if you have a distortion project, then you can actually do a lot of the legwork yourself, and then work with them. And then once you form a certain number of blank parts, they scan them, they make the file adjustment, they send you a file, and then everything matches. And I've got to tell you, I mean, I've used Distortion Arts a lot, and it seems like a very fragmented process, but it works very, very well. I don't think we've ever missed with their product and had to, make more than one iteration. So what happens usually when you start, and if anyone wants to see a movie of this, I can provide that. It's about a 10-minute movie. I didn't want to show it today. But you create a 3D model. Now, this is a model that can be done in AutoCAD. It can be done in SolidWorks. It can be done, really in any type of CAD program. From that CAD drawing, a mold is made. In this case, this is a resin mold, and it's mounted onto a vacuum box. So that vacuum box will actually get mounted onto the former. At the same time that mold is getting done, there is a file that's being created. And that's what we want it to look like. You want to have a tiki mask. Okay, so that's done. And then there's a grid that is sent down. I'm on the last step here. There's a grid that Distortion Arts sends to the former. Then the former will print about, we'll say 6 to 12 different parts so that all the repeatability is intact. And then they will send a file back to the former, or to the printer, where the artwork will be printed with the new artwork that matches the mold. If it's needed, the parts are coated. Not everything needs to be coated. It depends on the abrasion level. And then the printed parts are formed, and then they're finished, usually with the multi-axis robot or some kind of router. which is actually another really important test. It's a test that the ink will survive that process. Being the fact that we only have one version of ink, we have a high gamut. You need to have also the withstanding not to chip. So anyway, so we do very, very well with that. But that is a distortion process. Like I said, one of three ways. If I had to split it out, probably 80% of the people, 85% of the people are going to go trial and error. The rest, all but the rest, couple percent are going to go this route where they actually send out the distortion to the experts. And then some people are going to bring it in-house. So either one works. It just depends on your situation. So if we look at UV curable, and that really to us, there's competition there. Okay, there's solutions from other manufacturers, but they're all UV. So what this comes down to is latex versus UV. And I won't go through every one of these, okay? But anyhow, standard one set versus multiple sets. Ink thickness, one ink is 8 times thicker than another. Lots of operator intervention. Again, with latex printers, we've probably sold close to 70,000 latex printers in the last 15 years. And you don't have to do a lot of maintenance with these printers. Okay, they're super easy to run. They're ready to print when you are. And they're not as expensive to run because we understand people don't run them every day. That's why the print heads are user replaceable. Just like an office jet, printer, you can replace the print heads yourself. They're a lot less expensive, and over the cost of the printer, you're going to probably replace more print heads, but it's going to be a lot cheaper in the long run. We kind of talked about the elongation and the gamut before. No venting is needed with latex because you don't have any odors to deal with. And then lastly, if your customers are really aware of certifications, then really we've kind of led the pack with reasonable certifications so that customers can feel good about their purchase. So those are some advantages. So the printers themselves kind of look like this. There's a small printer on the left, a large printer on the right. One is called an R1000 and one is called an R2000. The difference in these printers really is just comes down to two things. It comes down to the width of the printer, whereas the one on the left is 64 inches wide and the one on the right is 98 inches wide. So you can run sheets however you see fit. Cut sheets or full rolls if you wanted to. They are hybrid printers, so they will run flexible media. For example, if you bought this to do maybe a little bit of thermoforming, but you did do a lot of signage on styrene, could you buy a 6-inch core with styrene and put it on this printer? The answer is yes, you could do that. Would your rigid color match your flexible color? Yes. If you do Coro signs on the R2000, is it possible to get 250 18 by 24s an hour? Yes, it's possible. And then the last thing really is the size of the ink. More expensive on the right, but the ink is less money. Less expensive to buy the printer on the left, but it will cost you more per copy because the ink comes in smaller containers, but it does carry a higher price. So those are rigid solutions. So I think everything I talked about until this point has pretty much been a rigid solution, right? It's been direct print, first surface or second surface, taking it right to a former or right to a laminator, whatever the case may be. Those are rigid printers. We also have roll-to-roll printers, and we call this our 7 and 800 series. Now these printers are about a year or 2 years old. Okay, I don't know how many printers we've sold. It's quite a big number, but there's two models. The 700 model comes, or 700 series comes in two models. On the left, there's what we call a 700, and on the right, there's a 700 white. Okay, so this is the first time white has ever existed at a printer that's, either around the $20,000 mark. Okay, and the reason being is when we created white ink, we enable the user to use it on demand. Meaning, if today is Thursday and I print a white job today, and I don't have to print a white job again until a week from Monday, then I can take the white out of the machine. I can take the heads out. I can put it inside the printer here, and it will keep those heads fresh until I want to use it again, and I won't waste any ink in the process. I won't fight with this printer to get it in a print ready state for white. But for those customers that might do, 6 to 8 to 10 rolls of material a month, this is a really good printer. It's got some other features on it. It reprints from the front panel. It has a maintenance cartridge, so you don't have to swab the print heads. Yeah, pretty robust, productivity solution. And then there's an 800 printer, which is about 15% faster. So not, earth-shattering faster, but again, 64 inches. It has a white model. The big difference between the 7 and 800 is the size ink container that it accepts. So this ink comes in 3-liter boxes. So you're really realizing a 20 to 25% savings in the ink by buying it in bulk. It's kind of like shopping at a warehouse store. You buy it in bulk and you save money. But the 800, being given the fact that it does have some faster throughput, its curing is a little bit more efficient. The duty cycle is about double of that of the 700. So not a crazy deal amount more money, but roll-to-roll printers, these do a great job. Now, how does this pertain to thermoforming? Okay, whatever films you want to print on, 2 mil cast films, whether they're optically clear films, whether they're translucent films, diffuser films, they all go in these printers. And these printers can print on those materials beautifully. They can be mounted to any kind of sign face, Panagraphics 3, FS1. They can be put onto acrylic, whatever the case is. Both of these printers, or both these printers series, all 4 printers, and the R series carry 3M MCS. So, for example, if you were going to do a vehicle on these printers with it could be 3M 180C with a cast over laminate like an 85, 18, 19, or 20, you would get 7 years marking and demarking. Architectural signage, depending on the application, depending on the film, you would get, upwards of 4 or 5 years, depending on what the overcoat is. So these do carry MCS, and the MCS covers not only color, but it covers white as well, which is kind of cool. A lot of whites aren't covered because what happens with whites is they turn yellow over time and they get really brittle. So for us to have our white included is real special. So not making this a 3M commercial, but if there are people there that use Avery products, maybe you wrap a car with 1105 Supercast and use a DOL film, or use Orifal products, ProSide products. Those all have warranties as well. Okay, and usually when you have these products, they are at the very, very high end of any warranty programs that they have. So coming down the home stretch here, I want to just talk about our ecosystem on the forming side. First of all, this is a work in progress, okay? Anybody that would ever tell you that they figured out an ecosystem for forming is probably crazy, because it changes. Everything changes. So for us to come up with a solution, number one, we had to get the 6 buckets right. Number 2 is we had to pick the right partners to work with. And number 3, we had to keep the system open. So we're not telling people you must do this. So, on the distortion side, remember I said there's 3 ways to do it. You can do trial and error. You can go to Distortion Arts up in Canada, or you can buy the gear and the software from Quadraxis. So if you want to do distortion any of those ways, that's your call. You can do that. File prep, same type of thing. Some people might use Corel, some people might use Creative Suite, the Adobe products. You can do that. But on the RIP side, usually it's Caldera or Onyx. Okay. Some people like to use SAI. They do make a driver for our printer as well. Okay. So file prep, ripping, things like that. That covers that. From substrates, we have a nice arrangement with Primex. We like Primex materials. We like their DigiHips product. The Corex products, a lot of our customers use, but there are other manufacturers too that make quality components. Of course, our printers, I think I spoke on them already. And then coding wise, now this is where, things become a little different because, there's hardware component to coding, and then there's a coding, actual fluid part of it. So fluid, we work with a company called Polymeric in Kansas City. They're a neat company. They've been around a long time. They have especially strong expertise in water-based coatings, but they also make a thermoformable UV coating. So if you were to make a product and you wanted to coat it, whether it was water-based or whether it was UV, maybe it could be anti-graffiti, they have adaptable coatings for that. And then as far as manufacturers go, you see 2 of them here. You see ATC and Berkel, or Berkla, depending on how you pronounce it. But those are very good coaters. We also have a partnership with Tech Lighting in Brea, California, that makes custom coating devices. But usually our customers get into coating because they do a lot of lamination, and coating's a lot more efficient, a lot less expensive. And then on the forming side, there's really just 2 people that we deal with, day in and day out, and that's Mac here in Chicago, and then Formec, which is a UK-based firm. So some of the smaller, I hate to use the word hobby formers, but parts formers, some of the the less industrial pieces are done on Formec devices. Mac makes things that are the size of merry-go-round. So so that's our ecosystem. Like I said, it's kind of a work in progress, but happy to be part of that. Happy to be part of the discussion we're having today. I hope I didn't lay it on too heavy for anybody today, but there's a lot of good technology in like latex, and there's probably some things maybe you didn't know. Hopefully we cleared them up for you. But in any case, as I promised in the beginning, I'd like to take any questions that you might have. I'll do my best to answer those. And Tara, if that's okay, we can open it up to Q&A and go from there.
Absolutely. I don't have anything in the Q&A right at the moment, but
okay.
Oh, I have one now. What is the, sorry, it just went away. Hold on a second. What is the life expectancy of an outdoor sign printed using UV latex on aluminum or Dibond?
Okay, so let's take that one apart. So if you've got an aluminum composite panel and you print first surface with a latex ink, all right, our durability statement is going to be up to 3 years unlaminated. Now, is that a great answer? Probably not. Up to 3 years. But that depends. If you're in the US desert Southwest, it's going to be more probably towards the 1 year mark. If you're going to be up in the Northeast, it's probably going to be more towards the 3 year mark. But again, with latex ink, the only thing you have to worry about is fading over time. You're not going to worry about cracking and things like that, because on the UV side, you would have to worry about cracking and crazing and all sorts of things as the substrate changes. But if you were to laminate a latex print, you could probably get 10 years out of it, just because the material is so durable. But fading is never really an issue for any major ink company, because they're all automotive pigments and they last a long time. But our general durability statement is up to 3 years. If it's something you're really interested in and you want to drill deeper into the durability question, we would be more than happy to furnish our durability guide for you. It's a PDF. It's probably 8 or 9 pages long, but that might clear up some things relative to certain types of material or certain climates. But that's the generic answer today.
So the person who asked that asked if, yes, please, if you could
Sure.
supply that. So
Well, if you
we
guys can capture that for us, we'll make sure that we get that. That's always at the
absolutely.
ready. It's always at the ready for us.
Absolutely. Any other questions?
Let me off easy today if there's just one question. That's pretty, I must have answered more than enough.
Just waiting a moment here, just in case anybody
Sure.
thinks of something.
Well, I'd like to think that your last presenter in the series, got most of the questions answered.
It appears to be, because we don't have
Alright.
any other questions.
Okay.
And Tom, if you want to send that information over to us, I can absolutely
Sure.
get it to this guest. I do want to thank everybody who attended. Thank you, Tom, also for your presentation. We have had a wonderful series this summer, and we want to thank everyone for attending. If you attended multiple times, thank you very much. And Tom, thank you again. If
Yes,
you
thank
have
you.
any other questions that you're not thinking of at the moment, don't hesitate to reach out. You can always send us an email at marketing@tubelight.com, or you can give us a call. Thanks again.
Yeah.
Everyone
Thanks,
have a great
everybody.
day.
Yep. Bye.